Gelatin, that soft, shiny, delicate ingredient that seems almost magical in so many desserts, has a far more complex origin than we usually imagine. Although its appearance is simple and its mild flavor barely interferes with other foods, its presence transforms recipes, adds texture, and supports structures that would otherwise be impossible. It comes from the collagen found in the skin and bones of various animals, a material that, after a long sequence of industrial processes, becomes the translucent powder we have all used at some point. But behind that apparent simplicity arises an inevitable question. How is this ingredient actually produced on a large scale? In this video, we are going to dive into its lesser-known origins and the monumental machinery that allows this product to reach kitchens around the world day after day. The story of modern gelatin begins with a figure few people remember, the American inventor Peter Cooper. In 1845, at a time when refrigeration did not exist and food preservation was a constant struggle, Cooper introduced a revolutionary new method for producing gelatin. His proposal not only improved the way food was preserved, but also opened an entirely new path to culinary stability. Thanks to his invention, it became possible to create preparations that were firmer, more resilient, and had a much longer shelf life, an urgent need in a century marked by the fragility of fresh products. Over time, this innovation became indispensable, especially during World War I and World War II, when armies depended on durable, protein-rich, easily transportable foods. Gelatin was incorporated into military rations, becoming a vital resource for millions of soldiers worldwide. But its impact reached far beyond gastronomy. With the advancement of science and technology, gelatin became a key component of the pharmaceutical industry. Thanks to its unique properties, it became possible to create capsules that protected sensitive medications, regulated the release of their active ingredients, and facilitated accurate dosing. Gelatin became a versatile, reliable, and crucial material in numerous medical applications. Meanwhile, in the culinary world, it opened the door to new textures, more sophisticated desserts, and foods that redefined what we understand as modern, practical cuisine. In its purest essence, gelatin is simply processed collagen, a protein extracted mainly from the skin and bones of animals, such as pigs and cows. It is a transparent product, easy to dissolve in hot water, and capable of forming an elastic semi-solid consistency when cooled. It is an impressively versatile ingredient. It can gel, thicken, stabilize mixtures, add shine, and provide firmness. That is why it appears in desserts, candies, meat products, dietary supplements, and even certain beverages. But to truly understand how impressive its production is, we must step inside a real gelatin factory. Everything begins at meat processing facilities, where parts containing high amounts of collagen are carefully selected. Most of it comes from cattle and pigs, since their connective tissues and bone structures are rich in this essential protein. When the animals are processed, the cuts intended for human consumption are separated, while the skins and bones, the true treasures of this industry, are set aside and stored specifically for this purpose. Afterwards, these materials are loaded onto refrigerated trucks and sent to highly specialized plants. There, they remain under strict temperature control, because any deterioration could negatively affect the quality of the extracted collagen. An average-sized plant can receive around 5 tons of skins and bones per day. Once they arrive, the materials go through an extremely meticulous washing process designed to remove residual fat, meat fragments, and any type of impurity. This initial cleaning is vital. The purity of the material will determine the transparency, flavor, and quality of the final gelatin. To achieve this, large rinsing systems are used, combining fresh water and mild chemical solutions capable of removing residues without altering or damaging the collagen fibers. These facilities are often enormous compared to conventional factories. Some produce more than 10,000 bags of powdered gelatin every day, ready for global distribution. The entire complex is composed of huge stainless steel tanks connected through an intricate network of pipes, ducts, and automated systems. Hygiene is absolute, and every stage is rigorously controlled. The temperature, pH, exposure time, and concentration of each substance are monitored in real time. This level of precision is what allows manufacturers to obtain a stable, safe, and consistent gelatin. After the cleaning process, a key stage begins, reducing the size of the raw materials. Bones, which are hard, heavy, and extremely compact, are fed into high-powered crushing machines that break them into uniform fragments about 2 centimeters in size. This reduction is essential because it facilitates the penetration of heat and the chemical compounds that will later participate in the collagen extraction. The skins, for their part, are cut into very thin strips using blades designed to make precise, uniform cuts. This process increases the surface area and allows the chemical solutions to act evenly on every section of the material, accelerating the controlled breakdown of the fibers. Once everything has been reduced in size, the materials are placed into enormous tanks filled with water at approximately 70 degrees Celsius. This heating serves several simultaneous purposes. It softens the fibers, helps break the bonds that hold the collagen structure together, and allows it to gradually dissolve into the water. Maintaining an exact temperature is critical. Too much heat could degrade the protein and ruin the production, while too little would slow down the process, causing delays and increasing energy consumption. To further enhance extraction, an acidifying agent is added, typically vinegar or purified acetic acid. This seemingly simple detail is actually a decisive step. The acid modifies the molecular structure of the collagen, making it more flexible, more accessible, and much easier to separate from the original tissue. Thanks to this step, the collagen is released evenly and can be transformed into a rich solution that will later be filtered, purified, dehydrated, and finally turned into the powder we all know. The process of extracting collagen enters one of its most important phases, cooking, a turning point where the raw material begins its true transformation. In this stage, the animal tissues, previously washed, selected, and fragmented, are submerged in enormous stainless steel tanks where they undergo meticulous heating. The temperature is never left to chance. It is controlled by automated systems capable of adjusting the heat to the exact degree required. This heat, applied with almost surgical precision, acts like a molecular key that unlocks the structure of the fibers. As the temperature spreads evenly throughout the mixture, the collagen chains slowly detach from the tissues and migrate into the water, forming a solution that becomes increasingly rich and concentrated. This process can last for many hours, sometimes even more than a full day, depending on the type of tissue and the level of purity being pursued, because the fibers must break down gradually. If it is accelerated too much, the proteins become unstable. If insufficient heat is applied, the release of collagen is minimal. For this reason, both the duration and intensity of the heating are always kept within a carefully established range. A temperature that is too high would overly fragment the proteins and reduce their gelling capacity, while one that is too low would make the process inefficient and energetically costly. As the fibers begin to break down, the liquid takes on an increasingly thick, dense, and dark appearance, similar to a concentrated broth. Suspended within it are soluble proteins, microscopic fragments of tissue, natural minerals present in bone, and compounds inherent to collagen. However, this solution is still far from usable. It exhibits noticeable turbidity due to impurities, traces of fat, and tiny particles that must be removed to achieve the purity level required by the food and pharmaceutical industries. This is where the next stage begins, purification, an essential process that determines the transparency, quality and stability of the final product. The first phase of this purification involves a complex filtration system designed to remove every visible and invisible trace of impurities. The hot mixture is pumped into a network of ceramic microfilters with pores so small they are completely invisible to the human eye. These filters operate under high pressure. The solution is forced through them, leaving behind solid fragments, organic particles, and residues that were still suspended in the liquid. The result of this stage is a noticeably clearer and more uniform liquid. The network of pipes that makes up this entire system can extend nearly 3,000 meters, forming an internal labyrinth that transports the solution through multiple purification stages. Each section fulfills a specific function: separating particles, reducing turbidensity, stabilizing the mixture, and preparing the collagen for the processes that follow. Even after this thorough filtration, the solution still contains dissolved salts and a significant amount of water that lowers the collagen concentration. To resolve this, the mixture passes through enormous columns filled with tiny synthetic resin beads called ion exchange resins. These beads act like chemical magnets. They attract and retain residual salts, allowing the solution to continue its path free of mineral impurities. Once this stage is complete, the mixture, now pure but very diluted, moves through long stainless steel conduits until it reaches the gigantic tanks where evaporation takes place. Here, the solution is heated in a controlled manner to remove excess water and concentrate the collagen. This process, known as concentration, is one of the most impressive in terms of efficiency. For every 2 liters of initial solution, only about 200 milliliters remain, a thick, shiny, viscous concentrate similar to honey. To guarantee microbiological safety, this concentrate undergoes a gentle but effective heat treatment designed to destroy any resistant microorganisms that may have survived earlier stages. Then begins the gradual cooling phase, a critical moment in which the collagen reorganizes itself, partially solidifying and acquiring that characteristic elastic consistency we associate with gelatin. Once it reaches the proper texture, this semi-solid mass is pressed through a perforated disc that produces long, thin strands known in the industry as gelatin noodles. These filaments fall onto a wide conveyor belt that passes through a series of drying chambers. Inside, currents of hot, purified, sterile air remove the remaining moisture without affecting the quality of the collagen. When the strands are completely dry, they pass through large rotating mills that grind them into a fine, uniform powder. At this stage, the pure gelatin is mixed with a variety of ingredients designed to enhance its flavor, appearance, and functionality in the final product. Sugar is added, which not only sweetens, but also acts as a stabilizer. Acidity regulators, such as citric acid, are incorporated to balance the pH and improve dissolution. Flavorings are also added, allowing for a wide range of varieties, from lemon, strawberry, and orange to more exotic blends, and colorants, which may be natural, sourced from ingredients like beetroot or turmeric, or synthetic, depending on the production line. Finally, to ensure that the powder retains its free-flowing texture and does not form lumps, anti-caking agents and stabilizers are added. These ingredients prevent ambient moisture from altering the texture and guarantee long-lasting, trouble-free storage. After this final blending, the gelatin is packaged into enormous industrial sacks of up to 1,000 kilograms, ready to be shipped to factories, distributors, and brands that will transform it into the commercial packets and presentations we all recognize. Thus concludes the extensive and highly controlled journey that transforms simple animal tissues into the powdered gelatin found in supermarkets and used in thousands of households around the world.